Are we on or not here? There we go. All right. Hi, everybody. It is lecture number 4 of AER 110 DE. And we're talking to Chris here about growing up in Massachusetts. And you can see a lot of weather there across some portions of southern New England. Let's see what we got there. Yeah, looks like that. Let's take a look at weather for that part of the world. Just not for any particular reason, but here we go. So let's see here. So right now, it looks like right here, that's it. That's Westfield, BAF, 65 degrees, and it looks like it's raining over here in Pittsfield and up to the north. Kind of cool. Hey, let's see what's happening at Mount Washington. I always love to see that. Whoa, okay. So let's take a look at a weather observation from Mount Washington and a few other crazy places too. So before we get into our weather here, we'll look at Mount Washington and also the South Pole, and we'll go ahead and look at the last 24 hours. So here we go. Go and expand. So we're looking at just METAR observations, which is something that all pilots must know about. So here we are at Mount Washington. This is their latest observation taken a little bit before 19Z. It's a correction, so they sent something out wrong before, but this is the real deal now. So winds are 290 at 43, gusting to 49, and the visibility, Chris, what's the visibility at Mount Washington right now? Chris, are you with us?
That'd be 0 statute miles.
0 statute miles. Does it get any lower than that? I guess maybe imaginary numbers. But yeah, it doesn't get any lower than that. And so they have some light showers of graupel. That's what that is. Freezing fog, blowing snow. And here is the ceiling right now. The ceiling is 0. So this is it doesn't get any worse than this. This is called 0, 0. 0 is the ceiling, 0 is the visibility. Not a whole lot of good flying in weather like that, especially when the winds are gusting to nearly 50 knots. And there's also very light icing. I should say icing. Okay. And how long has it been like that? Well, let's see. It was a little windier earlier. You can see right there. Okay, let's take a look at another crazy place to look at. This is the South Pole. So there are people who actually live at the South Pole, and I mean 90 degrees south. So here is the current observation from NZSP. The SP stands for South Pole, and that's the 24th at 1750Z. So this is their 18Z observation. Winds 120 at 4, and the visibility here, rather than in statute miles, is just in meters, and all 9s means good visibility. Ice crystals. So we've got ice crystals as the precipitation, and the sky is clear. So this is, we talked about this last time, a weather type number 76. It's the only type of weather and the only type of precipitation that can fall from a clear sky, and lo and behold, it's happening at the South Pole right now. Their current temperature is minus 63, and the altimeter setting is 2840. These are all pretty crazy values. But Chris, I have to just ask one question. Let's see if you have an answer to this. So we're looking at the weather here at, in fact, we'll go ahead and decode it. We're looking at the weather at the South Pole. It says that the winds are 120 at 4. You can see it right there, which would be east-southeast at 5 miles per hour. But if you're at the South Pole, Chris, what does that even mean? I mean, aren't all winds from the north, if you're right at that singular spot where you can't get any farther south? So what do you think? How do we determine winds at the South Pole, where the temperature, by the way, is 81 below 0 Fahrenheit? What do you think?
I think it's basically just where the majority of the winds are coming from. Likely there's multiple sets of winds converging there, but the main gusting is forcing that wind one direction, and that's coming from 120.
Right. Well, what does that mean? I mean, if the winds were 120, well, what does 120 even mean? I'll just tell you the answer. So at the very end here, it says all winds grid, which means that the 0 degree longitude, which is the prime meridian, goes all the way up to Greenwich, England, 0 degrees. We're going to call that north. And then the line of longitude, which is 90 degrees east, which is coming in from like India and place like that, coming down to the South Pole. We're going to call that east. And then the international date line, which goes to the middle of the Pacific and comes all the way down to the South Pole, we're going to call that south. That's 180. And then, of course, if something, yes, go ahead.
Could you draw it so I could get a better visualization of what you're talking about? Or I'm not sure if you're able to do that.
Yeah, maybe I could. Let me go ahead and do something here. We'll let's go ahead and add a new slide. We'll do this, and we'll just tell it to go. Okay. All right. Let's see what this looks like here. So, so here is the equator. This is 0 degrees. That's the equator. And this is 30 degrees, and this is 60 degrees, and that's 30 degrees south, and this is 60 degrees south. And here's Antarctica here someplace, and there it is right there. That's 90 degrees south. So this is the 0 degree longitude. This over here is 90 degrees east. Here is the international date line. This is 180 degrees. And over here, this is going to be 90 degrees west, which goes all the way up through like New Orleans. It goes through New Orleans. So all of the lines of longitude converge at this spot right here. And so we just simply put a little grid over the South Pole, and we say that if the winds are blowing from like this direction, we're going to call it 120, even though really it couldn't possibly be, right? So that's what all winds grid means. Does that make sense?
That does. That makes a lot of sense.
Okay. Or yeah, okay. So let's see. We're going to go back to this. So all winds grid. And if you're at the North Pole, all of the lines of longitude converge on one point at the North Pole. In that case, how do you determine wind? All winds are from the south if you're at the North Pole, unless you have a grid. And so that's what we're doing here. So this just goes to show that it's very cold there. I can actually show you a picture of the South Pole. Let's see here, South Pole. Here it is. Here's a camera at the South Pole, and there it is. And this is as of 1850 Z, which is right about now. So this is pretty much current. Now, the reason that you can see, and it looks like there's maybe a red light down here, is because the moon is full. The sun is below the horizon and will be until September, when they start going into their summertime. Of course, at the poles, the sun is either up or down. There's no rising or setting. And what's interesting is that if you were to look, if this was just a picture and you were looking at the south, we're looking straight south. So here we are in Mesa, Arizona. We're looking straight south, and over here, the sun would rise in the east and then peak in the south and then go down in the west, like that. But at the South Pole, it's just the opposite. The sun rises in the east, and you're looking north here. So this is north, okay? So straight north. It will rise in the east and go left, and then will set in the west. So everything is backwards. This looks like a star up here. I don't know what star that is. But anyway, it's 81 below zero at the South Pole, completely clear. Apparently they have a little bit of ice crystal activity, and this is where just a few people are wintering over at the South Pole. Down for maintenance. I don't want to hear that. Really? Down for maintenance? So here, we'll take a look at this instead. By the way, we can actually go to the South Pole. Let's hide this and go here. So there's the South Pole. And so all of the lines of latitude longitude rather, come into a single point right there. And you can see not too much going on at the South Pole, but and here's Australia up here. Here is South America down here. Here's Africa over here. So yeah, the winds are going very strongly from west to east around the South Pole. Meantime, we can also take a look at the North Pole. And these pictures, by the way, are from polar orbiting satellites. You can't use geosynchronous satellites when you're looking at the poles, obviously, because it just doesn't work. You have to be in a geosynchronous orbit. So here you can see the North Pole. So finally, we'll go back to just our regular satellite imagery, and here it is. We're looking at the West Coast. And you can also see the terminator right here. This is the sunrise sunset. And the sun is slowly rising. Let's see. There it is. You can see the terminator. So here we go. I'll come back to this. And maybe we won't come back to that. All right. So we'll come back and look at all this. So once again, things are crazy at Mount Washington and also at the South Pole. All right, so let's take a look at KOXR, KSAN, and KPHX. And we'll look at the last several hours, and something strange happened in Bakersfield. We'll take a look. All right, so we're going to go ahead and take a look at this. So the forecast, by the way, in Bakersfield had been for mostly clear skies. And we were clear until right here at 11:20 Zulu. All of a sudden, out of nowhere, we have a marginal VFR ceiling. We went from clear to 2,800 broken. And what's interesting here, we've talked about this in the past, is that when clouds develop, the temperature goes up. The temperature goes up because clouds are radiating heat. That's that latent heat of condensation that takes place. So you'll notice that the temperature was 11 degrees right here. And then the clouds came in and the temperature went up. And the temperature continued to go up with that overcast. So that's just a good indication of that. Here's the forecast. The forecast was, by the way, the forecast at 12Z this morning from your good friends at the National Weather Service did not include any low clouds. It was basically this line right here. If you at 20,000 feet, the skies went overcast to 2,200, and they never amended the forecast. And the rule is that they only amend the forecast if the forecast is off by 2 flight categories. That means that if you're forecasting VFR, you have to go to IFR. That goes through marginal VFR to IFR before they will amend the forecast, which makes it terribly unrepresentative. So earlier today, right here for a number of hours, we were overcast at 2,200 feet. But if you went to the TAF on ForeFlight, it basically said this. It said 20,000 few, which was unrepresentative, and it's just a big problem that the National Weather Service has. They need to actually change the way they amend the forecasts. All right, back to our weather, though. So it's really not all that bad in Oxnard, nothing but clear skies there, and clear skies are forecast. We are going to see some mid-level clouds broken at 10,000 right there, and that comes up at 6Z tonight. By the way, let me go ahead and go back to the satellite shot here and see what exactly happened. Why was it that we got these clouds that developed in the Central Valley? What's going on? Why was it not forecast literally at all? And not even the models forecasted. So what happened was we had a little marine layer, which has been generally plaguing the Southern California coastline for a long time. It actually kind of jumped over and brought some clouds temporarily to the Central Valley. Let's look at mid-level troposphere. You can see a low pressure system right here has brought in some of that cloud cover as well. If we look at the SKU-T, let's do this. So we'll go to Bakersfield and look at that. So you can clearly see right here the temperature and the dew point go up. They meet right about here, right around 2,800 feet. You can see the height right over here on the left side. And then once you get above about 3,500, then all of a sudden it dries out and warms up and everything's fine. But that's what came in earlier, and that has been the problem. In fact, if we look at the current observations all across, we'll leave New England. We'll leave New England and go back there for a visit sometime. So here you can see 3,500 broken at Bakersfield. Looks like we've got another ceiling which is developed. Over here at Navy Lemoore, it's 4,100. Here we have a couple of blue dots, and that would be marginal VFR, and Visalia now 2,800 overcast. Up in Fresno, just barely VFR, 3,100 foot ceiling. And along the coast, we also have some low cloud ceilings. You can see by the blue dots right there. But if you go all the way down here to the Los Angeles area, not too bad. LAX right now has a few clouds at 2,500, 4,000, and 6,000 feet, so no problem. Going over here to Avalon, which is at Catalina, they are overcast at 700 feet. So there are some low clouds there. Getting back to the forecast, let's see what we have. So we'll go down to San Diego. San Diego also had some stratocumulus clouds, 3,200 overcast, and their forecast is for a few showers in the vicinity, perhaps, once we get to about midnight tonight. You can see cloud cover, definitely cloud cover. And in the Phoenix area, no cloud cover really to speak of, just a few clouds at 25,000, otherwise clear skies, and looks like it'll be nice. There will be some gusty winds in the afternoon, 250 gusting to 20, and then at night it turns around to a 160 wind. So that's the way that's looking right now. All right, let's see. Barbara's with us, and let's see. We've also got Ivan. Okay, so very, very good. Hi, everybody. Good to have you with us on board this lovely Wednesday afternoon. We'll come back to.
I'm staying quiet, but
you're staying
here.
quiet. Okay, well let's see what's going here. Let me see if I can get this satellite shot back up. Oh, maintenance! I hate it when they have to have maintenance. So no maintenance. No cloud cover. We have to go to something else. So we just won't worry about it. All right. And as far as, okay, so what's going to happen with the weather? So we do have, we'll go to pivot right now. And we're going to take a look at the weather over the next couple of days. We're going to look at the 500 millibar pattern right here. Okay, and we're going to check out the continental version. Okay, we're going to be continental now. All right, so low pressure moves on through right here. And then a secondary push right here comes right down over the, not over the top of us, but just slightly to the east. Looks like it'll push into Arizona. After that, the question has been, will there be another low pressure system that develops? And here it is, coming over really the northern 2/3 of California. This will be for this coming weekend, Friday. And then another low kind of develops out to the west, and then another system comes through. So we get into May, and we quite often get into the doldrums, the summer doldrums. That doesn't appear to be the case this year, though. It looks like May could deliver a little bit of precipitation. Let's go deeper into the future with the climate forecast system and see what it says. So we have low right there, big low pressure system over us. This is a week from day after tomorrow, Friday, the 3rd of May. Looks like something's coming through. And then after that, we should have another episode of precipitation potential. That will be on the 11th. Looks like it's happening on Fridays and Saturdays. But then I believe we're going to start to see, well, there's another low pressure system right around the 19th. But then after that, let's see what happens. Okay, high pressure begins to build in a little bit, and things begin to warm up. Now, are we going to get any precipitation or not? Let's see what it says here. We're going to look at the regional. We're going to come here to regional, and we're going to look at precipitation. And here we go. All right. Is it going to rain? Okay. Well, let's see. We go through, I don't think it's going to rain over the Bakersfield, Kern County area. And there might be some drizzle or maybe a light shower down over San Diego. But for the most part, we have a very tight pressure gradient right there. You can see that right here, very tight pressure gradient. This is valid 00Z Saturday, which is Friday afternoon. Looks like a little green here, the little green there. And maybe a pile-up cloud situation south end of the valley going into Friday evening. But for the most part, no meaningful precipitation. However, over Arizona, it looks like there is some precipitation right there. Wow, I wonder if Phoenix and Mesa will get some precipitation and not California. We go all the way to the following Friday. There's Wednesday, Thursday, and here comes Friday right here. Anything? Let's see. It doesn't really show much. So it looks like it's going to be generally a dry pattern. Wait a minute, what's this? Now we're going into the weekend. Looks like there's some shower activity, even some snow up over the High Sierra of Tulare County. Maybe a little bit of sprinkle activity over Southern California, like around San Diego and Orange County. And then after that, we're pretty much done. So if it rains, how much we're going to get? Let's look. Here is
Miles?
Yes.
I'm not seeing the maps, the charts.
You're not seeing the maps. This is very, very important. Thank you for letting me know that.
I can see the charts or the maps.
Okay, then it might be just my video interface. That's all.
Oh, good. Okay, so it does show that I am sharing. I just stopped sharing. I'm going to start sharing again. So thank you for that. Okay, so and go. Should be seeing things. How about now? Now can you see it? Barbara? Hello, Barbara.
Not quite yet. Give it me a minute. But if other people can see it, don't worry about me.
Okay, and Chris, you said you can see it, right? And Ivan?
I can't see it.
Oh,
yeah,
good.
I can see it too.
Good. Okay. So we, all right. So we do have a little bit of precipitation here, and it looks like there will be a little bit of something perhaps down in the San Diego area. But all in all, generally fair weather. Let me see if I can get this to work. That's not working either. Okay, so it looks like College of DuPage is down. We hope to be back up at 1930 Z. Well, that's coming up in just a few minutes. All right. So we know that. Let's see. While we're at it, let's check out the computer models and see what they say here. So we'll take a look at Bakersfield, Oxnard, San Diego, and Phoenix, just for the near term. Yeah, the models weren't very good in Bakersfield regarding the low cloudiness we had this morning. Let's see what they say now. So here's Bakersfield. KBFL, does it have any ceiling? Ceiling would be down here under SIG, and it doesn't have any ceiling. You see the -88 means no ceiling. And the reason there's no ceiling is because sky coverage is 28%. You have to have more than half the sky to have a ceiling. So right there, we have 66%. And it says that the ceiling will be at 7,000 or 6,000 feet. And then we do have a little bit lower ceiling here, according to this model. Visibility is good. This means 10 miles throughout, so no problems there. And the chance for precipitation is 12% and 11%. This would be going into Friday with a high temperature of 70 degrees. Now we'll take a look at San Diego. San Diego does have ceilings. Here's the ceiling line right here, 2,700, then 3,500, then 2,700 again. So it looks like there is constant ceiling action down there. The chance for rain, though, the probability of precipitation is like nothing. Looking at Oxnard, we don't have any chance for rain there either, but we do have sky coverage, which actually diminishes and then comes back for tomorrow. Ceilings are in the 4,500 foot range, and then again 4,500. So no real low ceilings. I don't see any IFR. And of course, Phoenix is doing just fine, thank you, with no ceilings at all until the very end. Here's 4,700 foot ceiling with an 11% chance for precipitation. That'll be on Friday. I wanted to go a little deeper into the future to see if it shows anything significant. So for Bakersfield, by the way, we're going to be looking next week on Monday. We'll be talking about an introduction to computer models, and it's all about the numbers here. So we're looking at these numbers, and we'll get into how just an introduction to how these models are actually run and the theory behind that. For Bakersfield, temperatures in the 70s for highs, right at 70 on Friday. And then next week, we're up into the 80s. There's 81, 83, 83 for Monday, Tuesday, and Wednesday. And sky coverage, we'll see some clouds initially, but then once we get into Sunday, Monday, Tuesday, just no clouds at all. So that's good. In San Diego, let's see, cloud cover. Looks like we have some sort of cloud cover through Saturday, and then the clouds go away. They do come back, though, right here on Wednesday. That's probably the marine layer. Chance for precipitation basically is not there. The P12 is the chance for probability of precipitation of a 100th of an inch or more in a 12-hour period, and there's really nothing. And looking here at Oxnard, here's KOXR. This is for the Oxnard campus. It looks like temperatures in the 60s for highs, 50s for lows, pretty much ad infinitum. And there are some ceilings right here, and then we pretty much clear it out after that, so no real problems. Let me look at, we'll go here and take a look at cloud cover. We're going to go to this here. We'll look at regional, look at cloud cover now, just cloud cover. So cloud cover. And we're going to go into the future and see if there's any marine layer to talk about. So cloud cover. Okay, so here we go into the future. Everything in blue is cloud cover. And looks like it's clearing out in Arizona. We do have some clouds coming across the region here in Southern California, down around San Diego. And then, of course, the time is in the upper left-hand corner. So this is Friday at 12Z. Looks like some clouds south end of the South Valley. Looks like it's cloudy there. And then after that, looks like we completely clear out most of Southern California going into Sunday, Monday. There comes Tuesday. Wow, looks really nice there. And that's because high pressure is going to develop across the area. And there is some cloudiness coming up across Arizona on Tuesday. And then we go deeper into the future. Let me just look at the 500 millibar pattern. We're just going to look at 500 millibar winds just over our area here and see what it shows. So it shows that we have low pressure. Low pressure is right here. You can see the winds come around. It's like a little trough of low pressure. And then here comes winds. Now the colors are isotax. Those are lines of equal wind speed, and those are the red ones that you see there. That is all 80 some odd knots. So pretty strong winds there on Friday and Saturday. And then it looks like high pressure builds in and everything is fine. Looks like nice weather all in all. Then we do have a trough which comes through right here with some strong winds. And of course the winds will act as the dynamics for turbulence and perhaps some precipitation and clouds. This is valid Friday at the 03Z, which is actually late Thursday. And then that system just moves on out, and it looks like high pressure comes back. But wait a minute, here comes a little wave right here. There's a wave that comes through on Sunday evening. That's a week from Sunday evening. We'll go all the way out to 360 hours, and there's a pretty significant low pressure system. You can tell it's a low because all of the winds are moving counterclockwise, and here's the 558 height line right there. So that is a low pressure system. Go all the way out to 384 hours, which is valid 12Z on Friday the 10th. And low pressure is right here over Las Vegas and the Needles area. All right. So that is what we are looking at right now. Okay, let's go ahead and take a look at today's topic. And today's topic is a little bit of a special one. We are going to go ahead and move right into forensic aviation weather. So this, now we've learned so far in AER 110 a lot of intermediate concepts. And a lot of them have to do with METAR observations, and of course the basics of basic clouds and basic weather types. Last time we looked at every kind of weather that exists. And we've talked about things like latent heat, things like some of the gas laws, the adiabatic process, incoming solar radiation, which is short wave, outgoing long wave radiation, which is long wave, and the whole greenhouse effect and all that. Now we're going to be very specific, and we're talking about how weather is very impactful on your profession, flying. So we're going to look at a number of weather-related fatal mishaps. Now, just because there is an aircraft mishap does not mean that it's necessarily weather-related. There are all sorts of mechanical problems. There are human error issues that can take place. Air traffic control can have a problem, whatever. But quite often, weather is paramount to mishaps, and they don't always have to be fatal. But we're going to look at the top, well, more than 3. We're going to look at about 7 different weather-related mishaps, and see what we can learn about this, and see what type of weather really is dangerous. And you have to be particularly vigilant when you get into that kind of weather, or you too may have a fatal mishap. You don't want that. The worst of all took place many years ago, 1977, in the Canary Islands in Tenerife. This was March 27th, and this was, believe it or not, maybe you haven't heard about this, maybe you have. These were 2 jumbo jets, and at the time 747s were about as big as they get, and 2 of them collided full of passengers on a foggy runway in the far southeastern Atlantic Ocean, in the Canary Islands. Okay, so this is just off Morocco, just off of the Western Sahara. You can see it right down here. And of course, we generally have the winds, which are northeasterly. The flow is northeasterly. We have cold waters, very much like we have here over the Eastern Pacific. We have upwelling, which causes cool water. So a lot of fog can develop down here just off of Northwest Africa. And that's exactly what happened. So a KLM, Dutch airline 747 initiates a takeoff roll while a Pan Am 747 is on the active runway taxiing for takeoff. So this is the Tenerife aerodrome right there. You can see it's just one runway, and there is a taxiway, but this was a special circumstance because this is not the main aerodrome for that area. Many aircraft had been rerouted to this secondary airport due to terrorist activity at the larger airport. And this was back in 1977. And so this was there were aircraft that would fly from Europe to South America or to lots of spots. Anyway, so in this particular case, there was a communication complication between air traffic control and the KLM aircraft. Now, a lot of this would not happen today because of ADS-B, but that was not something that was available back then. So you have aircraft, you have zero visibility and fog, as you can see right here, and nobody knows where anybody's at. And that's really difficult, especially if you're taking off in basically zero visibility. So the KLM and the Pan Am, they were actually parked right next to each other. You can see this picture right down here, actually showing the 2 aircraft. Somebody got out and took a picture of, I think this is the Pan Am aircraft here, and they were taking it, let's see, the Flying Dutch. The Flying Dutch, and that would be the KLM aircraft. And so the KLM aircraft comes all the way down here, turns around, gets ready for its takeoff to the west-northwest. But the Pan Am aircraft is on the active runway, planning to come here and then take this taxiway over to the main taxiway, taxiway 4. But that didn't happen. And so the KLM was cleared for takeoff because of miscommunication, and 583 fatalities took place due to that. It was all due to thick fog. Nobody knows where anybody's at, but yet they are taking off, pretending that the runway is clear. Next is Kerman in Iran. This was in 2003. In this case, it wasn't necessarily fog, but it was a flight from Zeradan to Kerman. We're coming from here to here. The Iranian Revolutionary Guard was flying an Ilyushin IL-76. Everything seemed to be fine, but it was winter. You could tell by February 19th right there. And there was a lot of turbulence. There was snow showers, strong winds. And as the aircraft was making its approach into Kerman, it ended up crashing onto a Sirak mountain about 19 miles southeast of Kerman. And it did this because of snow showers, of turbulence, and just of not knowing where you're at. Again, not knowing where you're at. Just like in the Canary Islands with the fog, you were unaware of what was going on. And as a pilot, you need to always be aware of what's in front of you, what's around you, where you're going, what's the weather like, and never be in a situation where you are flying blind. Of course, again, this was 2003. This was prior to ADS-B. But anyway, it turned out that they just had controlled flight into terrain. There have been 884 incidents of that since 1935. So, also, there may have been some icing involved, perhaps. But the main thing is just simply not knowing where you're at and not being aware. So these are two catastrophic accidents killing hundreds of people due to a pilot not knowing where he's at. And I mentioned icing. This is another really bad situation. This took place many years ago, again in the winter. This is December 12th. So there was a flight that was taking troops from Cairo, Egypt, back to Fort Campbell, Kentucky. It was one of these real long DC-8s. And the flight, everything was fine from Cairo to their refueling location in Gander, Newfoundland. Everything was going fine. They landed in Gander. Of course, it was a cold, snowy day there. And then they crashed shortly after takeoff, bursting into flames right at the end of runway 22. They were taking off to the southwest en route to Kentucky, and they never made it more than about 3,500 feet. Why was that? Well, it had to do with icing. They were not de-iced before they took off. Everything seemed to be fine, even though there was snow and the temperature was well below freezing. Turned out the Canadian Aviation Safety Board checked it out, and the most probable cause of the stall after they had taken off was ice contamination on the leading edge and upper surface of the wing. So there you go. It's icing. So we've got the three aircraft disasters. The worst one of all was due to fog and not knowing where anybody's at. Yeah, you should never take off on a runway where you can't see what's right in front of you. That actually happened just a couple of days ago. Where was it? It was in Washington, D.C. It was Reagan National Airport. It was a Southwest aircraft and some other, maybe Delta, I forget. And they had started their roll, and there was a Southwest airline aircraft that was, I guess, cleared to cross the active runway. And at the last second, they just said, stop, everybody stop. And so that it was averted. And the skies were essentially clear. And how that happened, I don't know. But it all comes down to situational awareness, where you're at and what's all around you. When you throttle up and you're going down the runway full speed, you've got to know what's right in front of you. You really do. And if you're taxiing, you need to know what is on the active runway. Usually ATC is pretty good about that. And I say usually, it should be always. But in the end, it's up to the captain. It's up to you, the pilot of the aircraft, that's responsible for everything. If somebody else makes a mistake, you are still responsible for what happens. In this case, the icing had not been mitigated, it had not been de-iced. And I don't know why that is. But anyway, a total of 256 people died because of that icing situation. Speaking of icing, here is the somewhat famous Air France Flight 447. This took place in June of 2009, and it wasn't in the winter, it wasn't in the polar regions, it was in the tropical regions. Remember that. That's how important icing is. Icing can down your aircraft. Now you're flying 172s right now, and maybe it's not that big of a deal, but when you're flying jets through tropical thunderstorms, and that's what happened right here, it's a big deal. So this aircraft was flying from Rio de Janeiro to Orly Airport in Paris. Took off, everything was fine. They had cleared the Brazilian coast. They were out over the equatorial Atlantic. And of course, right along here is the international, I'm sorry, the ITCZ, the Intertropical Convergence Zone. That is where the weather from the southern and the northern hemisphere come together, and we have lots of thunderstorms there. And they can be very tall. They can be 50,000 feet or higher. And so if you were in a tropical thunderstorm with all of that moisture in the tropics being propelled vertically to your altitude, then you will get SLD icing, which is a super cool large droplet. And of course, the captain had already gone to sleep in the bunk in the back. First officer was there. And then all of a sudden they go through this tropical thunderstorm out in the middle of nowhere there, literally in the middle of nowhere between South America and Africa. And next thing you know, severe icing is taking place. It is affecting the instrumentation, the pitot tube. Of course, there's structural icing over everything. And the next thing you know, it starts descending. The autopilot tries to correct, and the angle of attack is crazy. And before anybody knows what's going on, I guess they wake up the captain, but it's too late. The thing plunges into the tropical Atlantic with 228 fatalities. This was severe icing in a tropical thunderstorm. All right, so that's 4 horrible things that took place, and 2 of them involve icing. Now we go to this interesting story of Juliane Koepke. So here she is as a young German girl in Peru, and her father is a biologist, and they're working, the family is working there, and she just graduated from high school, so she's like 18 years old. And it's Christmas Eve 1971, long time ago. Lanza Aircraft, which is Líneas Aéreas Nacionales Sudamérica, is a really bad airline, because what they do is they just cannibalize parts and engines and structural control surfaces, and it's really bad. Anyway, Flight 508 was a Lockheed Electra turboprop, and they had taken off out of Lima en route to Iquitos, and everything seemed to be fine. And of course, Juliane was on this flight from SPJC to SPQT. They were flying at 21,000 feet, and then they encounter severe turbulence in a thunderstorm. So now we're flying into thunderstorms, and lightning caused this cannibalized aircraft lightning struck the inboard right engine, which is right next to where Julianne was sitting, and it blew up. And the next thing you know, the entire plane is disintegrating. And here she is at 21,000 feet, Julianne, and she is now outside the aircraft, strapped into a 3 seats that are kind of together, and she is now upside down and beginning to kind of helicopter. She's like spinning upside down at 21,000 feet, going straight down. She's still strapped into her seat, falling nearly 2 miles into the Peruvian rainforest. You know, this is not a good situation. You know, how is she going to survive? Turns out that the cause of the accident was intentional flight into hazardous weather conditions. In this case, intentionally flying into a thunderstorm with a limping aircraft at best. So lightning strikes the thing. There's a severe turbulence. The plane disintegrates, and now Julianne is strapped to her seat, falling 21,000 feet into the jungle. And she's known to have been belted into her seat and somewhat cushioned and shielded. The outer seats of the row it remained attached to hers as part of a row of 3, and they are thought to have functioned as a parachute and slowed her fall. So she was spinning. It must have been, how can you even imagine what that would be like? You know, not knowing what had just happened. Her mother, by the way, was with her, had been in one of the other seats and not belted in, and she was just simply lost. The impact when she finally hit the ground was probably lessened due to a thunderstorm updrafts and the thick foliage of her landing site. Okay, so she actually survived the 21,000 foot fall to the ground. She then, and that was not the hard part. You'd think, wow, you know, she survived that. Then she spent 11 days in the rainforest, walking through water, trying to find her way out. 11 days, and you thought that it was the worst, you know, falling 21,000 feet from an aircraft that had just disintegrated in a thunderstorm. But no, it continues. So she's walking through the rainforest with the bugs and she was injured. She had cuts and bruises and abrasions. She dealt with severe insect bites and a maggot infestation in her wounded arm. And then finally, after 9 days, she was able to find an encampment, you know, and she has nothing to eat except, I guess, berries and leaves and things like that. How dangerous is it just to be in the jungle? She gave herself rudimentary first aid. She poured gasoline onto the maggot infestation. She came to a location where there was a little hut that she just happened upon. She was finding her way down like a creek, expecting to find something at the end of the creek. Anyway, she got to this place where there were no people there, but she did find some gasoline to pour on the maggot infestation. A few hours later, some lumber workers found her, gave her first aid, and took her to an inhabited area where she was airlifted to a hospital. Little did she know, after falling 21,000 feet and surviving, that was just the beginning. And by the way, there were 91 fatalities in this 92 passenger aircraft, including the pilot who flew right into a thunderstorm. So that is an amazing story. They actually made a movie out of Julianne Kepke's story, and she survives today. She's an older woman, and I think she may have moved back to Germany, but I'm not sure. Now we move on
Could
to.
you survive, Miles?
I'm sorry. Go ahead.
Could you survive that, Miles?
Could I survive falling 2 miles? Well, my name is Miles, and so I guess I maybe could. No, I don't know that I could. I'm 71 years old. She was 18 at the time. That probably had a lot to do with it. I don't know how anybody could survive. Well, what do you think? Could you survive?
Possibly. I think possibly if I have my phone Maybe.
Your phone, is that what you said? Your phone?
Yeah.
Of course, you're in the jungle and there's no cell coverage in the middle of the Peruvian jungle, I don't think. Maybe, unless you have one of those satellite phones from Starlink. Just to put an end to this particular story, it was an amazing, heroic adventure of epic proportion that anybody could go through that and live to however old she is now. Let's see. So she would have been graduating from high school in 1971. That's the year that I graduated from high school. Okay. So she'd be my age exactly. I guess she's 71 now that I think about it. And thought about that till right now. Anyway, that was flying into hazardous weather. Never do that. Never
Miles.
intentionally fly into it. Yes.
Real quick, my internet's about to go out. Is it okay if I just leave and join back on my phone with cellular?
Absolutely. Do whatever you need. And of course, remember, this is being recorded. You can watch this at your leisure later on.
Okay, sounds great. Thank you.
Sure. All right. Next, we go to a very, very famous aircraft mishap, and that is a Delta Flight 191. This took place on August 2nd, 1985. Maybe you've heard about it. This was a flight from Fort Lauderdale to actually LAX with a stop at the DFW. So they were flying in. They were going to be landing to the south on runway 17 center, and everything seemed to be fine. Everything was fine with a Delta Flight 191. It was an L-1011 arriving right about 6 p.m. So at 6:02 and 34 seconds, the tower clears the aircraft for an ILS approach to runway 17 left at 2,300 feet, with the note that there's lightning north of the field. Okay, so now you're beginning to feel what's going on here. Lightning to the north. About a little over a minute later, the tower says reduce speed to 150, surface wind 5, gusting to 15. Everything seems okay, landing at Dallas. And then a little over a minute after that, the captain is saying this is the black box. They're at 1,000 feet, coming down. And then 14 seconds later, the captain says to the first officer, watch your airspeed. And then a few seconds later, heavy rain is heard. The captain says, you're going to lose it. Push it up. Push it way up. Okay, so the way up, by the way, is an angle of attack greater than 30 degrees. And you know that's a bad idea. So when was it? Let's see. That was at 6:05:26. So 10 seconds later, the captain says, hang on to the son of a bitch. The angle of attack was greater than 30 degrees. So we're about to stall here. And then a few seconds after that, the ground proximity warning system says, whoop, whoop, pull up. Aircraft sink rate, 50 feet per second. And the captain declares a go around. That's at 6:05 and 44 seconds. 8 seconds later, the landing gear makes contact with a plowed field 6,300 feet north of the runway and about 360 feet east of center line. So the aircraft had been pushed down into the ground, had stalled, and pushed it slightly to the left. So the aircraft struck a highway street sign. Its nose gear touched down on the westbound lane of Highway 114, skidding across the road at least 200 miles per hour. The aircraft's left engine hit a Toyota Celica driven by a 28-year-old, killing him instantly. As the aircraft continued south, it hit 2 more streetlights on the eastbound side of the highway and began fragmenting. The left horizontal stabilizer, some engine pieces, portions of the wing control surfaces, and parts of the nose gear came off the aircraft as it continued along the ground. Some witnesses later testified that fire was emerging from the left wing root. So here's the aircraft, and you can see everything in red. That is fatal injuries from Delta Flight 191. The only ones who survived, there are a couple of yellows. Here's a yellow here, a couple over here. And in the very back, there were no injuries from, let's see, 2. There's a light blue there and a light blue there. 2, no injuries. We had some minor injuries all at the back. And the cause of the accident was a thunderstorm microburst. And here we go. This is so important. And this is something that can happen whenever there are thunderstorms. So what happens is that we get a thing called evaporational cooling. Now, you remember before, there is the latent heat of condensation, which makes clouds actually radiate heat. That's what happened this morning in the Bakersfield area. But the opposite of that is when you have precipitation that evaporates. Virga is what it's called. When that takes place, we have dry air coming in, and that causes evaporational cooling. When that takes place, now all of a sudden the air is denser, heavier, and it is rushing even faster to the ground, and we get a thunderstorm downburst. Because of this, 137 people died. Not all of them, but most of them. That was Delta Flight 191, which never made it to Los Angeles. They crashed at DFW. But as a result of this accident, there's a little silver lining here. NOAA was in the middle of their development of the WSR-88D radar, which is the current Doppler weather radar network around the entire country. They were upgrading the old WSR-57 radar from 1957. And so during this whole thing, which was called NEXRAD for Next Generation Radar, they decided to come up with this terminal Doppler weather radar, which is basically a 5-centimeter wavelength version of the standard 10-centimeter radar. Now, the 5-centimeter radar can actually see low-level wind shear much better than the standard 10-centimeter radar, because it's just simply looking at the smaller things and has higher resolution. And because of that, we have all of these terminal Doppler weather radars at 45 different locations all across the country, including Phoenix, by the way, and Sky Harbor, and over in Las Vegas as well, plus all of these other locations, including Dallas, where it all started. So because of that, I'm confident, in fact, it can be proven that lives have been saved. Because when low-level wind shear conditions are taking place in real time, ATC can make sure that nobody tries to land or take off. So that is the silver lining behind the famous Delta Flight 191 from August 2nd, 1985. We're going to look at a couple of other flights in which there were some fatalities, some Northwest airline flights. This is flights 1482 and 299. This was all in Detroit back in the winter, of course. Here we go with winter, December 3rd, 1990. So a Boeing 727. This was Northwest Orient Airlines. I think at the time it was just called Northwest. It used to be Northwest Orient. Long time ago. Anyway, where was I? So here we have a Boeing 727, which initiates the takeoff, striking a DC-9. Okay, so a DC-9 mistakenly on an active runway during thick fog. Where have we heard this before? So it's the same sort of situation. Again, no ADS-B, so this was a long time ago. So the DC-9 was cleared from the gate toward runway 3 center, but it missed turning onto a taxiway. So to correct that, the tower instructed the DC-9 to turn right onto taxiway X-ray, but instead it turned onto the active runway. And there you go. So they're on an active runway. We have a 727 taking off and striking the DC-9. So 5 seconds later, at 1:45 Eastern Standard Time, the wing of the 727 cut through the DC-9's right fuselage just below the windows. This cut off the number 2 engine, and the DC-9 caught fire, was destroyed, and the reason for all of this, in fact, you can see here right below, here's where the wings struck, and you can see much of the fuselage is just gone there. It was a lack of crew coordination. This, of course, was disorientation due to thick fog. Visibility was an eighth to a quarter of a mile. And then there was a reversal of roles by the DC-9 pilots, which led to their failure to stop taxiing their airplane and alert the ground controller of their positional uncertainty in a timely manner. And after intruding onto the active runway, never be on an active runway unless you know that you're the only one there and you're cleared to go. 8 people lost their lives due to the fire. So that was just another fog-related pre-ADSB situation. Then we go to the most recent aircraft mishap, which caused the fatalities. This took place at Gillespie Field down in the San Diego area right after Christmas 2021. So it's been coming up. It'll be, I guess, about 3 years, almost 3 years, 2.5 years right now. So there was an aircraft that was leaving John Wayne Airport, Santa Ana, was headed to Gillespie Field, just northeast of San Diego. And the weather was really not all that bad. In fact, the accident took place at 7:14 p.m. Pacific Standard Time. And you can see the observation right before that. Winds were calm. The visibility 4 miles in light rain. There was a marginal VFR ceiling at 2,400 feet. Temperature was 10 Celsius, 50 degrees Fahrenheit. And the altimeter 298.9er, no serious problems. There wasn't like icing involved. There wasn't a downburst. There wasn't a thunderstorm. There wasn't thick fog. Nothing at all like that. And so you might think, well, what's the problem here? It shouldn't be a big deal. It was marginal VFR, which is a kind of VFR with some precipitation. It was just light. Looking at the Miramar upper air sounding, it shows that really there wasn't too much going on. There was some low-level moisture, but the winds were not particularly strong. Below 700 millibars, winds were probably 15 knots, a little bit stronger up right at 10,000 feet, but no big problems. There was abundant low-level moisture, west winds of 5 to 15 knots. The freezing level was at 5,000 feet. So again, no obvious weather-related problems. So here was the plan. Here is the airport right here. They were coming in from the northwest. And in this case, we do have the ADSB data track. So they were coming in, and there are 2 runways there. There's a runway, I think it's 17, that they or maybe 18. It's this north-south runway right here. But at the last second, they determined that they would rather land on runway 27. So they were going to come around like this and then land to the west. That was the plan. All right, so here is the Learjet 35A. So they departed Santa Ana at 6:56. It's just a short flight to Gillespie Field. At 7:08 and 23 seconds, the pilot contacts the Gillespie Tower on GPS approach to runway 17. Yeah, it is runway 17. The tower reports the current weather, winds variable at 5, visibility 3 in mist, broken at 2,000, overcast at 2,600. All right, so that's all doable for experienced pilots that we have right here in a not too bad situation. At 7:12 and 3 seconds, just a little while later, pilot, airport in sight, tower says squawk VFR. So they squawk 1200. And then the pilot requests to land runway 27. The tower says IFR canceled and instructed to overfly the field and enter left traffic for runway 27 right. Okay, so far so good. And when was it? That was at 7, 12, and 13 seconds. So 17 seconds later, before they have overflown the field, tower says cleared to land runway 27 right. Pilot says they request runway lights to be increased for 27 right. The tower says the lights are already at 100%. Uh-oh. Okay, so that's your first clue that something's a little wrong here. Something's not exactly perfect. Sure, it's not clear and unlimited visibility. It is marginal VFR. There is a little bit of light fog. But here's a problem. They thought that the lights were not at 100%. So the Learjet overflies Gillespie Field at only 400 feet above ground level. Seems kind of low there. I don't know if that's even legal. On downwind, the Learjet descends to 700 MSL, then ascends to 950 MSL on the base leg. So they're on the base, ready to turn final. The last ADS-B was at 7:14 and 9 seconds at 875 feet MSL. That's going to turn out to be a problem because they strike power lines about 1.5 miles east of the approach end of runway 27 right. And there you can see the accident right after Christmas 2021. There is a wreckage debris field, which is 186 feet long, 90 feet wide. And there's the Learjet 35. You can see here's Gillespie Field over here. Here's runway 27 right. And here's the crash site. So what was the problem here? What was it? Was it weather related? Or was it just some sort of disorientation and lack of situational awareness? Or was it a little bit of both? Maybe it was a combination of weather and situational awareness. It was disorientation in marginal VFR conditions with rain showers and terrain, which may have been a contributing factor. These were seasoned pilots. They were totally familiar with the area. And there were 4 fatalities here, and there they are. These were nurses, by the way. These are nurses, and these are the 2 pilots here. It's an air ambulance, and so that's what they were doing. They were just simply itinerant, I guess, circuit nurses, and they lost their lives. Was it weather related? Well, I'll let you decide. Anyway, that's it. We've looked at a number of aircraft mishaps, and they have been caused by fog, by icing, by turbulence, by snow showers, by flying into thunderstorms intentionally, with a phenomenal story of Julian Kepke, of the famous Delta Flight 191 that crashed in Dallas, Fort Worth, but with the silver lining was the impetus for development of the terminal Doppler weather radar network system all across the country, which has saved lives. And of course, that fog situation in Detroit. And now this. So there are a lot of things to think about there. And I hope you do remember these aircraft mishaps. So it's time for assignment 2. And by the way, assignment 1 is also due this coming Sunday. So we have 2 assignments, and there are only a total of 3 for the whole weather portion of the course. Both of the first 2 are due midnight this coming Sunday. So describe 3 weather actualities, and by that I mean what you just heard about, which led to the featured aircraft mishaps. That's what we just looked at. So pick 3 of the 7 that we just talked about and just very briefly tell me what happened. And then a little bit off that topic is this. Here's a question out of left field. Why is the moist adiabatic lapse rate slower than the dry adiabatic lapse rate? And one page on that. And that's it. But that's not it. There is more. You need to take the mid-block quiz. So make sure you take the mid-block quiz. It is a quiz of, I believe, 15 questions. And go ahead and do that. Also, not later than midnight on Sunday. And then next time, we're going to be talking about an introduction to weather models. What exactly are those all about? We're talking numerical weather prediction. What a great idea. I mean, if you are a farmer or a rancher or you've been doing agriculture for thousands of years, who would have thought that you could forecast the weather just looking at numbers? So that's it for today. Let's see what we have here. Does anybody have any questions? Let's see, we have Ivan and we have Chris. Any questions about anything that comes to mind?
No question.
No
for me.
question. Okay, very good. All right, so just make sure that you do those assignments and take that mid-block quiz and have a great rest of the week, a great weekend, and we'll see you next Monday and we'll talk about weather computer models. Okay?
All right. See you.
All right. Have a great day,
Sounds great.
everybody.
Thank you.
All right, bye-bye.